Designing for IoT brings new challenges and complexities to the design process. As you might see that designing for IoT is fairly different from traditional web mobile applications. Most of the IoT devices have limited screen space and the interactivity happen between the user and the IoT device is fairly non-conventional than web or mobile applications. At the same time, in IoT, design refers to both the hardware and the software. So traditionally, when we talk about a mobile or web application, you will think about a user interface of a mobile phone or a smartwatch. But in an IoT device, you will be looking at how to design the hardware and then how to design the software and how they interact together as one single unit. There are different facets in designing IoT applications or systems. As you can see in the figure, there are several design areas that you need to think about. UI and visual design, interaction design, interusability, industrial design, service design, conceptual model, productization, platform design. So in these all different kind of design, the top ones are usually visible to the end users. And then the bottom ones are more likely or invisible. They just work behind the scene, but the end user don't get to see them. Over the next few slides, I'll go through each of these areas very briefly. UI or visual design is very straightforward. Most of you are very familiar with user interface design in traditional mobile and web domain. In IoT, it is fairly stay the same. It is also important to highlight that when you say user interface, that doesn't necessarily mean the visual. It could be audio, or it could be gesture based. For example, some of the devices work for voice, like Alexa, which triggered by the voice. So in this area, you talk about or you think about how the visual appearance or the user interfaces look like. In interaction design, we think about how the device would interact with the users, how the users know what to do, how to accomplish a particular task, what are the actions need to be involved, how the user interact with the particular system in such a way that at a later stage they would remember what they did, how they would undo something, a particular action that they already performed. It is very likely we will end up creating user flows or low fidelity or medium fidelity interactive prototypes rather than static ones to make sure that designers get full understanding how the end users might use the IoT system. Another important aspect is end users most likely would expect to learn how the device works by interacting with it rather than reading an instruction manual. So the system should be resilient enough that not only it should perform the task what user need, but also guide them through the process in a correct order. In interusability design, we think about how to design a system that there are different components, but they work together to provide a single, unique, coherent service. This is fairly new to design world, especially this is more useful for in IoT domain where different devices work together to provide a single service. So the best way to explain is that you can see in this image there are multiple different form factors of devices providing a particular service of perhaps showing a movie. But because they are in different form factors, they can be programmed to do certain things. Not only they can individually perform the same task like watching the movie on the TV, as well as if you decided to move around, you can watch the same movie in the mobile phone. But also you can use the mobile phone to consume additional content related to the movie while you are watching the movie on the television. So this means that there's another layer of design which we call interusability. We need to think about how each of these devices would work together and complement each other, and also be able to use their own potentials, because not all the devices are same. They have unique capabilities. It doesn't matter that TV has a bigger screen. Sometimes a particular task might be fit or more better suited for a smaller device. So for example, mobile device could be used as a remote controller rather than using actual remote controller to change the TV or the increase volume or do any kind of interactions. So in this kind of design, first you need to think about specifying which functionalities belong to which device, and then create a design guideline that span across multiple devices. And after that, we need to think about cross-device user flows. Finally, we need to think about designing multiple devices and UIs working in parallel. Industrial design is a well-known area, but before IoT, it rarely became part of a software development project. But because of the IoT, where bring the software and hardware together, you increasingly see both hardware and software developers working together. So industrial designing, we think about aesthetic appearances, functional design of physical hardware, the form factors, material capabilities, and also we think about what kind of electronics we use, how the communication happens, does the material affect the communication, how the inputs and outputs are working, what kind of design thinking that you need to put in if you are using particular type of input. For example, if you are using voice input, how the form factor or the aesthetic appearances need to look like. So all this kind of hardware related design we think about within the industrial design area. Service design is pretty much the backbone of in any IoT device or any IoT system. As we discussed earlier, usually IoT devices are supposed to be invisible and providing a service that the end user needs. Most of the IoT devices are ongoing, providing ongoing services to the end users. So when you're designing services, you need to think about how the different types of devices or components work together to seamlessly provide a coherent service to the end user. In addition to the services provided by the device itself or the interactions, we also need to think about customer support interactions, instructional guides, in-store experiences, email communication, notifications, and entire user experience around software updates, firmware updates. All these different types of services need to be designed when you are talking about an IoT application system. Conceptual model is the understanding that you want your end users to have about your system. So whether you actually develop a mental model or not, your end users are going to develop their own conceptual model. And if their conceptual model is different from what you expect them to develop, then the users are going to struggle with the system. So as a designer, the objective is to make sure that somehow the users are developing a mental model or a conceptual model which is equivalent to what you develop. In that way, your system will behave according to what users think that the system would behave. Otherwise, they would perform a particular task and the system is not responding as they expected. They will be upset. They will be doing a lot of things that they should not be doing. interacting with the system, taking wrong actions. So it will create a lot of problems if the mental model that you initially develop for your system is not the one that the end users develop in their own head by looking at the system. Probably you all of you may have gone through similar systems. Sometimes you see a particular, or you get to engage with the system, but you never engage with a particular system at all before. But by looking at it, by using common sense, by using similar systems or being heard about similar systems, you have a gut feeling that how a particular system should work. So that is the conceptual model we are talking about. So as long as that conceptual model is fairly aligned with the conceptual model developed by the developer or the designer, the actions you take seems to be aligned with what you think the system should behave. The key is that users should feel that they are in control. They know what they are doing, even though they may not have fully understood the system. Because when you have a mental model and you try out few things, and if those few things work, then users become quickly comfortable with working with the system. And then at later stage, even though it might not be 100% alignment with that mental model, their mental model and your mental model as the developer, it is not going to be a problem. But at the beginning, or at least regarding the major functionalities, if the mental models are different, then at the very beginning they will be very frustrated, and most likely they will never use it again. In productization, we talk about defining a compelling product proposition. For example, when you are developing an IoT application, there has to be a value that why the end users need to pay for it, directly or indirectly. So for example, the questions would be, does the product solve any existing problems, or does it help to solve a problem more efficiently, or is it the product help to save any cost, or does it bring more convenient? So if you think about a market, existing market, there are three options. Either it has to be a low cost product, niche product, which means very unique, or it has to be a new type of product that can be sold in the existing market. Or it could be a new product for a new market. I think there is also a transition between existing market for a new market. For example, when the first internet connected smart thermostat come to the marketplace, they could identify as a new market. But after that, many companies developed that, and then the smart thermostat become existing market, and then there are many choices. So if you're a company that comes to the particular market segment later, then they will need to compete either low cost or a niche type of category, because there are already existing products in the marketplace. Even though this is a very important part of the design, it is not necessarily for user experience designers, but user experience designers would come into play if you are building a product that is niche, or it is helping to overcome any particular usability issue that has been an issue in the existing products. It doesn't matter how much time, effort you spend and do a fantastic job in designing all the IoT system, unless there is a value proposition, because otherwise the end users are not going to invest on it. Platform design is the last facet of the Internet of Things design framework. Platform is basically a software framework that hide the low-level details from developers and make it the developer's life easier to program these different components easily. At the very basic, those platforms allow developers to connect hardware devices to a internet quite quickly and easily. But more increasingly advanced platforms will provide a variety of different functionalities, from interoperability, for example, connecting different devices from different manufacturers together, be able to combine the data coming from different devices together and make centralized decisions. Or there could be platforms who embed advanced analytic functionalities or machine learning functionalities, which allows developers to mix and match and develop new kind of applications within the platform itself. Most of the time, these platforms are available across desktop computers and mobile tablet computers. It is also important to note that these platforms are sometimes targeted to proper developers who develop IoT solutions. Sometimes they are easy enough to be used by people who have little bit technical knowledge but not professional developers, but these platforms allow them to create new workflows or some kind of event detection applications by drag and drop things and quickly stitching these different hardware and services components together. We usually call these type of category of people as hackers or makers. They are not usually developing things for other people, but they are part of end users who like to configure the environment in a much more advanced way than a typical end user who will accept whatever the developer is developing as it is. Most of the time, these advanced platforms are not necessarily focused on user experience. They are designed to address a lot of technical issues behind the scenes that typically programmers otherwise have to spend a lot of time manually doing it by themselves. This could be like communicating with a particular type of device, because these devices might need some kind of driver or be able to understand the data types coming out from this particular device, and they need to be transformed into a particular standardized format. It could be that these devices are built in certain kind of protocol or handshakes where you need to sometimes the devices sleep and you need to make them awake in order to communicate. There are different patterns of communication happens in each IoT device because they are developed by different people, and also it also depends on the purpose of the application. For example, if it is IoT device that is like a doorbell or a doorbell video, is differently behave from a coffee machine, which you can pretty much sleep almost all the time, but in a door ring bell you need to be alert if there is a motion, something like that. So each device is different, so that is why there are these platforms develop advanced functionalities to create these bindings or adapters or plugins which usually do the hard work in between a centralized platform versus a particular IoT device. So most of the time it is not user experience based, but there are platforms which allows you to customize how the user sees the things. There are, if you look at this Open Hub, which is open source a smart home platform, it actually has about at the time of this recording, it have about 3 to 4 different user interfaces. They are uniquely varies. Each one has their own pros and cons, but different people prefer different type of user interfaces. So some platforms allows to sort of configure in such a way that different users could see different user interfaces, even though the behind the scene it is exactly the same platform. And then more advanced functionalities could be like new device discovery and adding devices and application to the systems, managing devices, users, administration tasks, data retentions, managing shared data across different applications and services, There could be a lot of things need to be happen behind the scene in order for developers to create different types of applications for the end users. Therefore, most of the time it is about non-user experience tasks, but there are user experience based functionalities within certain IoT platforms. I would also like to invite you to take go and look at these different IoT platforms and see how they are being designed and what kind of functionalities they provide to the developers to make their development process much easier. What you are looking at in this slide is another different smart home system called Home Assistant. You can see there are some similarities between the previous Open Hub which we looked at. In this one, there are a lot of different plugins that you can install. Each of these plugins are designed to help with a particular task or make some of the development tasks easier. These plugins are usually developed by the official developer of the platform, as well as they usually provide other developers to develop plugins, so the rest of the world can use their plugins easily. So this is very similar to the mobile applications ecosystem, where different people have different mobile apps, and then they make them available to the rest of the world using a app platform or app store. Similarly, it might not be in this case in IoT, it may be not straightforward app, but it could be different services or building blocks that which developers could easily use to combine and develop novel IoT solutions. Increasingly, one of the key challenges that these platforms aim to handle is the heterogeneity of the devices, because many different manufacturers build their own IoT devices and systems, and typically it is not fair for the end users or consumers to ask to buy the same kind of devices, because that creates a monopoly ecosystem which is bad for the pricing and the fair competition. Therefore, in order to create a more open and transparent IoT ecosystem, these centralized systems which coordinate the task of connecting different IoT devices within smart homes, even in outside smart homes, they should be able to connect different devices from different manufacturers. That is why these platforms play a key role in making these open and transparent ecosystem more accessible for developers. In the next couple of slides, I would like to explain what are the key differences between user experience design in traditional software development domain and Internet of Things. Throughout this lesson, we learned that user experience for connected devices is not just about developing user interfaces and interaction designs. We went through the IoT design framework, which requires the software developers and designers to think about the interusability, industrial design, service design, conceptual models, productization, and platform design. Now I would like to go through a few design considerations that will help you to understand how these IoT application designs clearly differs, and then why you need to care about that within the user experience design process. As you know from mobile phone experience, embedded devices often save power by connecting only intermittently to the internet. What this means from the user experience point of view is that part of the system can be out of sync and creating discontinuity within the user experience, so you should be able to expect that to happen and manage it accordingly. Another consideration is that latency on the internet is out of our control, and it is always, we need to assume that internet is not reliable 100%. What does this mean is that even though we expect physical things like switching on a bulb or pressing a button, we expect that the devices to be respond immediately and reliably. But in IoT world, this might not happen. So we need to have contingency plans put in place. Again, we discussed that the code can be run on many different places because IoT devices are heterogeneous and distributed. One particular system, like a security system, could have multiple components where the code can run on many different places. At the same time, other than the particular IoT hardware devices, there could be more controller devices like management screens or mobile phones or web applications. So there are a lot of different places you can run on the code. So we need to make sure that we are utilizing them inappropriately and also thinking about how to best position these code executions to give a better experience for the end user. This also means that we need to predict how the system would or should perform when certain parts are offline. The fourth consideration is that devices are distributed in the real world, which means that the social and physical context of use is complex and varied. One good example is that in an IoT solution, the same functionality might be exposed through different means. For example, switching on a particular device could be done through physically pressing a button or over the internet or using the mobile phone, where people will be located in different context. And then, for example, the feedback you give once the user complete the task might be different. For example, if it is a button switching exercise near the device, you could give a feedback in a certain way, and then that feedback might not be seen or heard if the person is using a mobile phone. Then there has to be a different type of feedback. Another key consideration is that functionalities can be distributed across multiple user interfaces. What does this mean is that the designers need to consider not just usability but the interusability, which means that there could be IoT solutions that hardware does not have a user interface. Then if there are any configuration that need to be made regarding that particular IoT device, there has to be some associated web interface or a mobile interface that allows the end users to do the configuration. So if the device is not capable of providing the end users the ability to configure itself, it should provide some kind of a mechanism using other companion devices to help the end users to configure itself. The other consideration is that most of the information processing is expected to happen as an internet service, which means that the devices are collecting the data and then sending to the cloud to do the processing, and then you get the information back. But the key challenge is that it is not single device sending the data, it is multiple devices around the house. For example, sending the devices data to the cloud, and then the cloud do the processing and give feedback to the end user as a overall, rather than sending data about each particular device. This could be true for like a security system where there are multiple motion sensors, cameras and other sensors that would detect intruders or any other events. But in reality, the end users are not interested in individual components, but they are interested in the security state of their house. So when you are developing a service like that, you need to think about it is not about end user interacting with a particular device, but they are interacting with the entire ecosystem, which is more like a service rather than individual single device. Another consideration is that remote control and automation tasks are like programming like activities that end users might have difficulties in understanding. For example, when you unlock a door remotely from office to someone to drop a parcel, then the challenge is it is not direct manipulation like similar to your opening door when you are at home. Because when you're at home, when you open the door, you are there, then you can close the door and then you see and get feedback on what is happening. But when you're doing remotely, it is cognitively a little bit challenging and different than when you do it physically. And also the feedback mechanism are not necessarily direct. For example, when you're doing this kind of task over the internet, you probably might get a notification when you open the door, and then what happened, the internet breaks, and whether you don't know whether someone closed the door or what happened. So then how do you handle this situation as an IoT solutions provider, which is you need to have backup plans, or you need to develop a confidence or a trust with the end user, saying that, okay, if the internet, something happened on the internet, this is what you usually happen. So it will secure the door automatically if the internet connection breaks down. So these kind of tasks are not natural to the end user. So it might need some kind of a confidence building between the end user and the IoT solution in order to make them trust and work as a team in the future. Another design consideration is that there are many different technical standards at the moment. So it is quite challenging to connect different devices together at the moment. We talked about the platforms before, which intend to address this issue. But still, when it comes to device communication, there's an intermediary requirement in order to translate this communication between devices. But if we had a technical standard, it would have been much easier that without an intermediary. Because when you're having an intermediary, the problem is that there's another node, right? Another component that could go bad, could be hacked, could be not available, broken. So then it disrupts the entire communication. But if there are common standards the devices can communicate, it makes it easier or reduce any kind of disruption that could happen in the middle, with the middleman who translate the communication. The another consideration is that complex services can have many different users, many user interactions, user interfaces, devices, rules, and applications. What does this mean is that if you remember previously we looked into some of the diagrams that become these relations extremely complicated, and what could happen is that if the management or the administration tasks become much more complex, and if the users cannot understand in a reliable way that how the system works, they will pretty much switch on the devices, or at least they will partially switch off certain functionalities because they don't know how they exactly work or how to manage them. Another important design consideration or the unique difference between IoT domain and the previous mobile or web domain. IoT enables us to capture and act on data that we didn't have before, because it's hardly someone would develop applications many years ago depend on the data coming from temperature sensors in a house or a coffee machine, or trying to track what kind of coffee people drink and what time or what kind of activities people perform in a particular day, and how the weather correlates to the coffee consumption. Those kind of creating creative and new kind of applications wasn't possible many years ago. But with the IoT now we are increasingly getting more and more data. But we also need to understand how the designers could use this information as a design material within their design process and then get the best out of that. Because at the moment what we have seen is that people collect, or the software developers design applications to collect a lot of data. But it is not clear exactly how they are going to use and what is the exact benefit that the end user gets. So most of the time they just collect for the sake of collecting data rather than actually considering these data collection and retention as a core design principle within the design process.